Hi, my name is Mansi Sharma and I am a data science and business analytic intern at Sparks Foundation. So, in this internship, my first task is to do the prediction using the supervised machine learning technique. So, in this, I have to predict the percentage of a student based on the number of study hours he or she has devoted. For this, I have used the Python language and I have done or implemented this on Jupyter Notebook. So for this, we have been provided the data set. In the data set, we have the 25 records and two columns, that is hours and score. So hours are the time which students have devoted and scores are the percentage score which they have attained. Then moving to our code which I have implemented. So first I have done the thing that I have imported all the libraries. So I have imported pandas library for analyzing the data. Then I have imported numpy as np for various multidimensional operations. Then I have imported matplotlib.pyplot as plt, which is used to perform graphical plot into the context. And then after I have implemented the, or you can say imported percentage matplotlib inline, which is used to plot and renders our plot in same browser and sets the backend of matplot library to the inline backend. Then after that, I have imported Seaborn as SNS. So Seaborn is a Python data visualization library which is based on Matplotlib and provides a high-level interface for drawing various informative visualization. Then after that, I have imported train test split from sklearn.model selection library. So basically, it is a function in sklearn model selection for splitting data arrays into two subsets. That is obviously our training data and the testing data. Then after that, I have imported metrics from sklearn, which is used to get the accuracy of our model. And after that, I have imported linear regression function from sklearn.linear model, which will be used for making various predictions and operations. Then I have imported mean absolute error, mean squared error, and R2 score, which will be used in our model evaluation in our implementation. So the next thing I have done is I have loaded the data set. For that I have used PD, that is our pandas. Okay. So pd.read.csv, in this I have given a URL where our particular data set is in a CSV file. So when we have executed it, we get the particular print statement that is successfully imported data. Then after that, for understanding of our data, that whether our data is same as the one we want to implement, then we have seen and understood the data that first we have get the first 10 rows of our data by the command data.head 10. So by which we can see and we can cross check that whether it is the same data or not, and how much columns we have in our data and how much rows are there and what they are displaying. So you can check by giving either 25, or you can check either by giving nothing in this. If you will give just data.head, so you will get the starting 5 rows. So after that, I have used the command data.describe, which is used to get the description of data such as mean, or you can say count. So these are the things you can get by data.describe. Then the next thing I have done is I have used data.shape. So it is to get that how many columns, how many rows are there. So I get that there are 25 rows and there are 2 columns. Then after that, I have given data.info. So it is to get the information of the data set, such as like what are the data types in the particular data set, and whether the values are null or not null. So we will get all the things by giving this command data.info. And then the next thing we have done is we have done the data visualization. So for that, we have used the sns.setStyle dark grid. So it is for setting the style of the grid. Then we have done is sns.scatterplot x is equals to data hours. So in this we have set the x equals to hours and y is equals to scores, and we have given that these dots, or you can say these O-type dots will be in color red and the size will be 75. Then we have given the title to look the presentation more nice. We have given that it is a comparison between marks versus studies hours, and we have said that how much size the title will look like. Then we have given the y label and the x label, that what will come on both sides of the plot, and we have given plot plt dot show so that we can see this particular plot. For getting more good visualization, we have also seen the box plot, that how our data set is visualized in a better way. And I have also visualized both of the columns independently, like hours and scores, to get the more proper understanding. Then the next thing I observed from these visualization is that both the marks and the hours that we have studied is having some correlation between them. So, what I have done to get the confirmation of this correlation, I have done a plotting of regression line. So, for that, I have done is SNS dot regression plot, or you can say REG plot, x data, in which x is my arts, y is my scores. And then I have done is plt dot title, that is for giving the title of this plot, and size is set, that how much size of the text will appear. And I have given plot plt dot y label and plt of x label of that particular plot. Plt dot show then is used to get the particular plot, that how it will appear. And then I have printed the correlation. So there, by the correlation, I got the thing that the variables, okay, both of the variables are positively correlated. We can see the values and we can get this thing, that both of them are positively correlated to each other. Then the next thing we have done is we have done the training of our model. So in this, first we have divided the data into values and labels, or you can say we have divided the data into x and y. So here what we have done x equals to data dot ilog, and then we have given the particular arrays for getting the values. So here x represents the array of values in ours column of the data, and y equals to data dot ilog. Then we have given the array values, and here y represents the array of values in score column of the data. Then after that, we have been splitting the data in two from sklearn.model selection library, and from there we have imported the train test split. So I have told this thing in the starting also, that the train test split is a function in sklearn model selection which is used for splitting the data arrays into two subsets, that is our training data and the testing data. So in this, what we have done, we have used, see this thing, okay, it is important thing, that is we have chosen 20% of testing data. Okay, so our data is choose 20% for testing. That is why we have given that our data will be 20% for testing purpose, and remaining 80% we have used for training purpose. Okay, so see this thing, inside that we have given x train, x test, y train, y test is equals to train test split xy, test size we have given 0.2, and random state is equals to 0. That means every time we will execute this code, so the output should not change. That is why we have said that it should not be random. Okay, random is equal random state we have given as 0. Then the next thing we have done is we have been fitting the data into a model. So what we have done now, we have implementing it using the library, that is sklearn.linear model. From there we have imported the linear regression. So for that, what we have done, we have now doing the training of our model. For that we have used the linear regression function, and then we have given the command regressor.fit xtrain bytrain. So basically what we are performing the training of our model, and when the training will be completed, we will get a print statement, that is training of model completed. Then the next thing that we have done is we have been plotting the test data using the train data set. Then what we have to do first in this, we have plotted a regression line. So for making a regression line, okay, what we have done, we have given a command line is equals to regressor dot coef coefficient underscore star x plus regressor dot intercept. It is for making the regression line. Then we also want to know about the slope. Okay, so for that we have given regressor dot coefficient, or you can say coef, and I have also given a print statement so that I can see here that what is the intercept. So both of the things I have taken here. Then I want to plot my particular test data. For that I have used the scatter plot, and I have given the command plt.scatter xy plt.plot x line color red. Okay, so what I have said here, I have set the color of my line as red, and then I have given the plt.show for showing the particular plot. Then the next thing, we can see the plot, that how our plot is appearing here. And see, then what we have done, we have said that we now are getting that what is our training score and what is our testing score. So for that, what I have done, I have taken the training score by regressor.score x train and the y train, and I am getting the value as 0.95155. This value I am getting, and for the test score I am getting by regressor dot score x test y test, that is by 94. Then the next thing I have done is I have been making the prediction of percentage of marks that will be scored. So for that we have trained our algorithm with good score. Okay, till now we have done that thing. We have been training our algorithm here, and we are seeing that how the process will go on. So the next thing that we have to do is we have to make some predictions now. So for that we have used y prediction is equals to regressor dot predict x test. Y predict. So here we are predicting the scores of testing data of ours on the basis of our trained model. Then we are getting an array that what will be our predicted stores. Then what we have done, now we have to make the comparison, okay, whether there is difference, there is much difference, or there is like slight difference between the actual versus predicted scores. So what we are doing, comparing the actual y test set and predicted y data we get with each other. So for that we have used the pandas, and we want it in a data frame. So we have given this command pd.dataframe actual y test predicted y prediction, and we also want that how much difference should be in the predictions. So we have given this different error y test minus y prediction. It is to get the difference, at how much difference is there. Then what we have done, see this thing, in the particular task we have been asked that how much predicted score the particular student will get if he or she studies 9.25 hours a day. So what we have done for that, we have used this prediction. Okay, so we have given regressor dot predict 9.25, that is the time we have given, and what we have done, we have get that predicted score if a student studies for 9.25 hours is our 93.691. This is, we got the predicted score. Okay, then see this thing. Now the last thing comes, that is evaluating our algorithm. For this, I have used some of the methods. That is, the first one is mean absolute error method. So for this, for why it is used to measure the average magnitude of the error in a set of predictions without considering the direction of it. So basically, by that I got that the mean absolute error in this is 4.18. Then I have used the mean square error. So basically mean square is used to get the average square difference between the estimated values and the actual values. So for that I have done the same thing. I want to get the mean squared error of the y test and the y prediction. Basically we are comparing the things, okay? So what we have get the thing that the particular mean squared error is 21.59. Then I have calculated the root mean square. So it is used to calculate the square root of the average of the square differences between the prediction and the actual observation. Then what we have done, see, we have given the same thing, that is our mean squared error for the testing and the prediction. And see this thing, then we get the value as 4.64. Then the next thing we have done, that we have calculated the R2 score. It is used to get the goodness, okay, that how much good our particular prediction is, okay. So for that, what we have done, we have get it as 0.94. So it is near to the 1, but we consider if it is 1, it is the best. Then what we have done, we have want to get the accuracy of the model. So for that, what we have done, we have used the metric. Do you remember that in the starting the of the explanation I was telling about libraries? So here there I used the particular metric, okay. I've imported that thing which is used to get the subset accuracy. So it is used to get the accuracy of model, and we get that the accuracy of model is 94%. So that's all I have to tell about this implementation, and thank you so much.